Thank you so much, and good afternoon to everybody on the house. Let me just say all protocols observed, and all the professors and all the students. Thank you so much for giving a little bit time to us here. My name is Christo Jones. I'm responsible for coding and robotics grade R to 9 in the general education and training band. I'm also responsible for technology grade 7 to 9 at the national platform. The coding and robotics curriculum is a product of many years of curriculum development. We originally had a draft curriculum for coding and robotics. That draft is currently implemented in pilot schools. The draft curriculum is in 1,770 pilot schools. That includes primary as from grade R to 3 schools up to grade 9 schools. The coding robotics is implemented in LSEN schools, multi-grade schools, full service schools, as well as mainstream schools, so that we can have a broader sense of how we'd love the coding robotics to fit all types of learners basically in our school system. I'm going to share the slides with you for now. Coding and robotics. I'm not sure if my slides will be moving. Just checking. Okay. Curriculum and assessment policy statements. These are the statements that every teacher needs to follow in terms of completing the curriculum. And for coding robotics, this is what we have. Most countries offer coding robotics as an extracurricular activity. Philippines has introduced coding and robotics as a subject. In primary and secondary schools. Sorry, Philippines has introduced coding. Australia recognizes the importance of technical skills and has included coding as a subject in its education system. South Africa is the first country to introduce coding and robotics as a core subject. In terms of coding and robotics, this is what I'm going to talk about. The strands, the strands that must be covered in the coding and robotics curriculum, the competencies. As you all know, we are all striving now for a competency-based framework, which means learners will be assessed in terms of their competencies in the schooling systems. The specific aims of coding and robotics, the specific skills that coding and robotics are covering, the goals of coding and robotics, and then I will be going a little bit in coding, what is the coding that we're doing in robotics, and exactly what we're doing in digital skills. I think my colleague yesterday, Ms. Karina Labuskachne, has indicated to you that we wish to link the CAT and IT curriculum in the FET to the coding and robotics. Coding and robotics is a means for us to make sure that our learners take up CAT and IT in secondary schools. These are the strengths of coding and robotics as a subject. We have coding, which deals with decomposition, pattern recognition, abstraction algorithms, and debugging. And then we have robotics, and then we have digital concepts. In terms of the coding is a process of creating a logical set of instructions that a human or computing device can understand and execute, which requires a deep understanding of computational thinking and problem solving. So from grade R, already we are exposing the learners to have a set of mind for a computational thinking mindset, as well as we are making sure that they have a design thinking mindset. In design, we're doing this in terms of the robotics. Design thinking process will cover inspiration, ideation, and implementation, which is very much like the design process skills. where you have investigation, design, make, evaluate, and communicate. So the robotics are very closely linked to the technology subjects. And then in digital concepts, we are doing digital citizenship, digital awareness, and of course, digital skills. This curriculum integrates these skills. So you cannot do coding and robotics without applying in a sense some of your digital skills. I think as I go on, you'll understand a little bit more. Robotics deals with the design, operation, use of robots that can be programmed, perform tasks autonomously or semi-autonomously, or by direct control. It presents the learners with opportunity to see their thinking, design, and code in action. When you design a curriculum like this curriculum was designed, we made sure that our concepts and our definition of terms are globally accepted. You can't say coding is this in France, for example, but in another country, it's something else. The competencies in terms of coding and robotics. These are the codings competencies. We move from C1 to C7, robotics R1 to R7, digital concept D1 to D10. These competencies are done from grade R up to grade 9 on a progressive manner, which means C1 identify and decompose the steps required to solve a problem into logical set of instructions, ignoring irrelevant details, will be done by the grade R learner at a very elementary way. But the grade 9 will do it at much more advanced way. The same with all these competencies. So every teacher will do these competencies over and over and over again until at the end of grade 9. At the end of grade 9, we will have a learner that can do both coding and robotics. These are the specific aims. We aim to develop computational thinking skills to solve problems. The problems can be of any nature. It doesn't have to be only, it can be in this, you can solve a math problem, you can solve any problem using a computational thinking skills. Advanced design thinking to develop creative and human-centered approaches to solve problems. Become part of a generation of creative, innovative system thinkers that can use coding, robotics, and digital competencies to express their ideas, foster creativity, critical thinking, collaboration, communication, and innovation, function ethically and effectively in a digital and information-driven world, develop a critical awareness of how technologies impact society at large, instill self-efficacy and confidence to deal with situations requiring computational thinking, design thinking, and problem solving. And then it prepares for future careers in STEAM-related fields. But with coding and robotics, you know, those fields are ever expanding. We currently don't know how many careers, how many possible careers can come out of this coding and robotics curriculums. So it is actually a very progressive curriculum. Adopt a culture of being self-directed, lifelong learners who can apply their skills in a wide range of contexts and situations. Adaptable, flexible, and resilient learners. That's what we aim to get. These are the specific aims. We are focusing on computational thinking skills in terms of the coding, and we are focusing on the design thinking skills in terms of the robotics. The design thinking skills has been there all along for a long time in foundation phase in terms of the life skills curriculum, where the learners were building artifacts or products as part of the life skills. So it's not that it's totally new, it's just that in terms of robotics, these are the skills we also focus on. This will include design thinking skills, include inspiration, where they come up with an idea, and develop the idea, the research idea, ideation where you make an idea, the product, and implementation when you can test and you can prototype your product. In terms of computational thinking, we're dealing with the abstraction, decomposition, pattern recognition, and algorithm. Many of these skills in terms of the computational skills are also linked to much of the maths concept in the numeracy curriculum, especially in the foundation phase. You'll notice that I'm talking much about foundation phase because that's where we need to ground these aspects. But at the other phases, we also do them in a more advanced way. The curriculum sets ambitious goals for developing coding, computational. I think I said this already. And then the computer programming is a highly cognitive skills, which requires mastery of multiple domains and is acknowledged as being difficult to learn, making it essential to take into account the cognitive loads imposed on learners, as well as abilities to absorb this knowledge during the teaching and learning process. While we developed the coding and robotics curriculum, we still needed to recognize and know that learners at that very young age, foundation phase, are still very much playfully minded. They want to play as much as possible, and through play, they learn quite a lot. So our coding robotics doesn't take away from the fact that learners need to play. In coding, these are the concepts we are dealing with, the practices and the perspectives. We're dealing with concepts such as algorithm, sequence, loops, conditional decisions, operators, logic, data, events, debug, representations, parallelisms, and automation. The practices are practices of abstraction, decomposition, pattern recognition. The perspectives are expressing and creating, questioning, connecting, collaboration, and then also choice of conduct. This I will try to unpack the coding, unpacking the coding specific aims. Programming or coding involves computational thinking as well as skills related to computational thinking, such as problem solving, critical thinking, creative thinking, algorithmic thinking, and reflective thinking. Mathematics, as well as other subjects domains, is often applied as a context, as a context, problems to be solved for learning to code or programming. So they can use their coding skills to solve a mathematical problem, for example. Computational thinking is a set of cognitive skills that is essential in programming. In robotics, these are things we deal with. You just need to remember robotics is also a vast field, a very huge field. And then in the GET, we cannot possibly do everything that is in robotics, but we consider the following concept, practices, and perspectives to be crucial. We do motion. They learn about sensors, actuators, controllers, logic, power sources, automation, and then learn about instructions and how to communicate and using coding as well. The practices are computational thinking, design thinking, prototyping, which involves like making and designing and constructing a model. Algorithmic design, testing and reconfiguration, reflection and iteration, creative thinking, logical thinking, creating robotic artifacts. The perspectives expressing and creating innovation, questioning, collaboration, perseverance, choice of conduct. And then we deal with the robotics, theoretical aspects that we deal with is such like what is a robot, components of a robot, design and build a robot, design thinking and design process, coding the robot to perform a task, and then this is how we linked to the coding specific skills. Other subject domains are often applied as a context, tasks that robots must complete, problems they must solve for learners, for learning about robots. Design thinking is a human-centered approach that encourages creativity and innovation when gathering user-focused products, services, or experiences. And then, of course, we have the digital concepts where we have to make the learner aware that he's part of a global network of citizens that are digitally connected. Awareness of different types of computing devices, awareness of networks, concept of input processing, use digital devices, patterns to communicate, responsible ethical behavior in the digital world, responsible ethical use of digital tools, being aware of that, what is it now? Copyrights and how people can infringe on your privacy in the digital spaces, in the digital space, network space. Unpacking digital concepts, technology versus information technology versus information and communication technology, ICTs. Understand the difference and the similarities. D1, which is now digital skills 1, D4 and D5, and also D3, computing devices, SIT, and ICT tools. So these are the digital concepts that are dealt with in terms of the digital strength of coding robotics. The digital skills are like the glue between coding and robotics. That's what brings them together. So what I just read to you now is just that the skills that are used for doing coding and robotics, basically. The approach that we use is a problem-based learning. We give learners from grade R small, manageable problem, and then they learn in small groups. They, for example, they also do like pair programming, where and they work in groups, and where creative thinking and where collaboration is actually encouraged. Learners are encouraged to discuss and design problems, solutions to problems together. We are in also deliberate practice improvement, feedback-driven metacognition. This is the approach that we are using. Currently, we have a curriculum that is approved by Umalusi. And this curriculum has been gazetted on the 7th of June, 2024, meaning currently schools will be using this curriculum from next year. The curriculum now in schools is just a draft. It has been refined with certain aspects removed and others included based on public comments that was published about the draft curriculum. So the draft curriculum was sent out to the public. Public gave us comments and recommendations. Even Umalusi gave us directives in order for us to have an approved curriculum. The public comments was talking about the affordability of devices. It was talking about concepts taught in coding and robotics at the time at which they are too complex for learners at certain stages. So all of those things needed to be addressed in finalizing this Umalusi approved curriculum now. These are the benefits of coding and robotics as part of curriculum offering. It has become a life skill and modernizes a school curriculum. It equips learners with essential cognitive skills. It enhances computational thinking. It develops critical thinking. It enhances problem solving. It encourages logical reasoning. It improves performance in STEM subjects. It encourages creativity and innovation. It develops confidence, motivation, and self-efficacy, persistence, and resilience, as coding often involves troubleshooting and overcoming failures, which fosters resilience and persistence. Sometimes a problem is relatively easy to solve using pen and paper, but quite challenging to code, as coding involves absolute logic and precision. So this is how we envisage coding to be happening. In the foundation phase, it is totally unplugged, which means we don't need to use any device to do coding and robotics. In the intermediate phase, we introduce the intermediate phase learners, that is learners from grade 4 to 6. We introduce them to basic devices like Raspberry Pi or other microcontrollers from grade 4 onwards, and microcontroller from grade 6 onwards. In senior phase, we also use basic devices like the microcontrollers and robotics kits. Senior phase is from grade 7 to 9. Foundation phase coding and robotics with the overall aim towards a holistic development of children. During their formative years in primary schools, the foundation phase curriculum focuses on unplugged coding or programming. The reason also for this unplugged coding or programming was, remember now we had a draft curriculum, and the draft curriculum actually made schools dependent on buying a lot of more expensive devices to do the coding and robotics. And now with unplugged coding, it makes coding and robotics accessible to all learners in South Africa, which means all schools in foundation phase grade R to 3 can do coding and robotics, and there's no more the the constraints of costs. Unplugged coding deals with cognitive load and significantly influences improving learners' performance of computational thinking and learning engagement, and also confirms the teaching it also confirms the teaching value of interactive unplugged programs. Therefore, great care was exercised to align coding and robotics concept to similar content taught in a specific foundation phase subject areas: mathematics, numeracy, languages, and life skills. We tried to make it as easy as possible by linking it to the subjects that the learners already know or are already engaged with. That's why we can confidently say that doing coding robotics will increase learners' ability to solve mathematics as well as scientific skills at a later stage. These are the resources from grade 4, as I told you previously, but this is just devices, e.g. the Chromebook, Raspberry Pi, or similar such as Orange Pi, the Potato, plus screen, keyboard, and mouse. Software that we use is mostly Scratch, which is a free software that can be downloaded onto any device, a laptop, a cell phone, a tablet. Robotics. We also, I think we'll just see the revises, the software, the resources needed for robotics, as I previously talked about, the microcontrollers, the sensors, and all of those actuators. The other textbooks, LTSM that's needed is textbooks, but textbooks will be developed based on the curriculum that has been recently published. And currently the publishers are busy interacting with these textbooks and making sure that they develop textbooks for coding and robotics. We have currently busy we are currently busy versioning coding and robotics into all official languages so that learners can do coding and robotics in any of the official languages in South Africa. So that is a current a huge process, because whereas Afrikaans is very well developed and concepts are already established, we still need to develop or create or make new words basically for coding and robotics in the other languages like Isipedi and Isixhosa and Xitsonga and all of those. But we are at a very advanced stage for that, with the Xhosa versioning being done, finished, the Sotho being finished, as well as Afrikaans finished. But we have to wait for the other languages, which is still a challenge. That is currently where we're at in terms of the versioning. From 2026, this coding robotic tabs will be available in all the languages. We are using block-based coding or programming. We are not doing Python, Java, or any of the coding, text-based coding languages. Block-based coding makes it easier for all our learners to do coding robotics. We are doing block-based as well, because we want all our learners to be able to do coding robotics. But we also found that it will be easier for them to move to text-based coding from grade 10 up. Our coding robotics curriculum is aligned to the one in the TVET colleges. We do coding robotics up to grade 9. If you want to go on with coding and robotics as a subject, you will have to go to TVET colleges where they offer coding and robotics. Otherwise, in the FET, we also aimed that coding and robotics can link to digital technology, to IT, CAT and IT as well. So our subject is very much linked to CAT and IT, especially in the coding section, whereas the robotics section also linked to the technology subjects like mechanical, electrical, and civil technology. In intermediate phase and senior phase block-based programming, by abstracting away the textual complexities, helps to reduce the cognitive load in the intermediate phase and senior phase curriculum, as it always allows learners to focus on the problem and the foundational coding concept, as well as the underlying logic of their programs. Research indicates that learners achieve substantial learning gains in algorithmic thinking skills and are more able to transfer their learning from block-based to a text-based programming context. Also, great care was exercised, I think, we to align coding and robotics concepts to similar content taught in other subjects, like mathematics, like natural sciences, and NS-Tech, sorry, natural science and technology is one subject in intermediate phase, and creative arts. I think we talked about the resources for grade 4 to 9, but it's in the slides, and I think maybe the slides will be shared to all our participants. These are how the content progress from grade 4 to 9. This is just an example showing that whatever we do in grade 4, we will still do it in grade 5 up to grade 9, but in a progressed manner. Let me just give you an example. In grade 4, we are doing singular conditions with answers, input value as reference, comparison, and fixed value calculations. Where in grade 5, we're doing singular conditions with else answer, input values as reference object, reference comparisons. And then we are doing in grade 6, use of iteration, simple with variable conditions, change the backdrop, draw shapes with loops, forever loops. I think you get the idea. We progress every concept per grade up to grade 9. That was a progression of coding, and then this is the robotics. Firstly, we deal in grade 4 with the virtual robot, where they will interact with a sprite in the virtual space, until they are also in grade 5 they move to a more block-based coding for robotics control, and microcontroller is done then. Every grade, the number of resources improves as the learner's understanding also improved. And every grade, the resources needed for coding and robotics is increased as well. I think this is just again up on the resources required in coding and robotics. I think I need to stop there, but I think I need to stress again that general education and training, GET, all the subjects there are actually there to give the learners a taste of the subject, where they will then in grade 10 start to decide to say, I want to do whichever subject they want to do. And that's why we cannot go in depth into any concepts we're dealing with within the GET, and that's why we have this currently. I think I will also mention that the Coding and Robotics Curriculum was developed by head and IT specialists, by HEI, higher education institutions, as well as general education specialists. For example, the technology subject advisors, technology teachers, natural sciences, foundation phase educators, and foundation phase managers were involved in the design of the latest curriculum.